So for a question like this, we want to keep in mind, as we state on our triple T document, that even though we don't want to look at the answer options right away because they'll only confuse us, it can be useful or helpful to look at the answer format. And notice when we look at the answer options, we see that all of these are in what we call rational exponent form instead of the initial radical form. So let's go ahead and take these out of the radical form, put them in rational exponent form, and apply some properties of exponents. So let's go ahead to page 34, which is side 3 of our math reference document. And notice these two images at the top are exactly what we're going to be referencing. So first off, the concept of radical form versus rational exponent form. And then we'll eventually come here to the properties of exponents. So first off, keep in mind the analogy I provided in class. As far as in elementary school, we did long division, right to left, but we would read it as 10 divided by 5. We ignore this middle school kind of version because it's not really helpful in our analogy here. And then here, the high school format is top to bottom, 10 divided by 5. So very similarly, notice in radical form, which kind of, the radical looks a lot like a division symbol. You might have confused it when you were younger, as I did. But the same idea is true. We're going to read it from right to left, knowing that if there isn't a written exponent, it's assumed to be a 1. And if there isn't a written index here for the root, it's assumed to be a 2. So for example here, this is 64 to the 1/3, 64 to the 1/3. Those are equivalent. So in this case, we already said that if there isn't a written exponent, it's assumed to be a 1. If there isn't a root, it's assumed to be a 2. So that is x to the right to left 1/2 times, because of this, let's rewrite this as, keep in mind that the unwritten root is a 2 if it's not there. You have y to the 5/2 over x to the 3/2. Let's go ahead and put this over 1 so we can see that x to the 1/2 is in the numerator. Now at this point, there's two ways you could apply the property of exponents. You could look at this as, well, since we're doing essentially division and you have the same base, what would we do with these exponents? Well, according to our math reference document, notice these 5 properties here. What we would do is technically subtract top minus bottom. However, if we do so in our particular situation, we're going to get a negative exponent, and I try to avoid negative exponents if possible. But now that I say that, I'm looking at the answer options and I see negative exponents. That's pretty rare. So it can be useful to look at the answer format when you're trying to determine what's the best approach. Well, 1/2 minus 3/2, you could use your calculator if you want, but that ends up being negative 2/2, which is equivalent to negative 1. So just based on that part, I'm definitely leaning very heavily to option B, but let's see how this plays out. That takes care of the x's. They're not really canceled out, but I sometimes cross them out once I've dealt with them. And then we still have the y to the 5/2. So yeah, that matches perfectly with B.